MacMaths, MacMaths, let's do some maths today. Hello and welcome back. I'm going to go through the SUVAT equations. I'm going to go through on this lesson just questions. So this is just question support for exercise 9C from the Pearson book. I'm going to go through selected questions, but in future when I do go through 9D, so I'm going to do a 3B as well and go through 9D, I'm going to go through every other question on that one, or pick certain ones out, but I'm going to just do the first one out of exercise 9C and jump to some of the harder ones for this first run, just so you can see those being done, okay? And I hope this gives you confidence to do them yourself. You're going to have to allow me thinking time when I'm doing these as well, so sorry if I'm stalling a little bit. I am trying to get them through sort of fairly quickly as well, because I'm on tea tonight and I'm making homemade pizzas, sourdough pizzas, so I've got them on the rise at the moment, okay, for my family. Here we go, guys. So number one in exercise 9C, so this is mechanics, is you're going to see with each one of these I'm going to just draw a diagram and I'll go through this quick as I can, okay? So put them on pause and have a go at them first, of course, by all means, do that. So number one, a particle with acceleration of 3 meters per second at time t equals 0, velocity is 2, find the velocity at times t equals 6. Now when I've copied out the questions, by the way, I've shortened them, so it always says a particle travelling in a straight line, and there's more words involved in it, okay? So here we go, a particle. Do it the same way as me. Always draw yourself a straight line from A to B and mark the key points and put the information on. So a particle with an acceleration, I always put acceleration at the top. Time t equals 0, the velocity is 2 meters per second there. Now that's the initial velocity, so that has a u. And we want the velocity here at time t equals 6. Okay, so that takes 6 seconds to go from there to there, and we want to find this one here. So it's simply, we're just going v is equal to u plus at. How do I know how to use that one? Just because I've done so many of them, I know that I've got t, I've got a, I've got u, so v is the only thing that I don't know. So this is the formula that I'm going to choose to use. And I'll do it in red, so v is simply 2 plus 3 times 6, and that's simply it. So v is equal to 6 3s are 18, 20 meters per second to the minus 1. Simple as that. Okay, so they don't get much simpler than that. The first few are all like that a little bit. Okay, get your diagram in. I'm going to jump straight to number 7 now. I don't know why I did 7, so I hope you can read that okay. I did it in brown. It looks okay, you'll have to zoom in on it. So a train slowing with deceleration of 0.6. Now you've got to be careful with this one. So here it is, a train slowing with deceleration of 0.6 meters per second. So the acceleration here, because it says deceleration, we're going to use it as minus 0.6. In other words, it's slowing down by 60 centimeters every second. It's going 60 centimeters per second slower every second. That makes sense. And it's traveling, it passes a signal, so it passes a signal here at the start at 72 kilometers per hour to the minus 1. And 25 seconds later, so this is t is 0, and here is the end, t is equal to 25, it passes a second signal. Find the velocity in kilometers per hour at the second signal here. Okay, so we're going to use for a, for the velocity, we're going to use v equals u plus at, because we've got all the same information as we had last time. But this is in meters per second, or it should be. There we go, it is now. This is in meters per second, this is in kilometers per hour. So I'm just going to change this. So this is 72,000 meters per hour. Okay, every 3,600 seconds. So if we divide that by 3,600, we get 20. I can see that 20 meters per second. So we're not going to use this. We're going to use it in meters per second. So 72,000 kilometers every hour, which is every 3,600 seconds. So divide that by 3,600, and we get 20 meters per second. So if we use it in this now, we're going to go v is equal to 20, and so it's going to be minus 0.6 times 25. Okay, so 20 minus 0.6 times 25 is equal to 5. There we go, that's the velocity. At this point here, so that's after 25 seconds, a deceleration, so it's minus 0.6 is the acceleration going in, and it started off with 20 meters per second. It does say velocity in kilometers per hour, so it does that every second. So if we times that by 3,600, 5 times 3,600, it does 18,000 meters per hour, which is 18 kilometers per hour. Okay, so we've just changed it to kilometers per hour by timesing by 3,600. Okay, and then essentially dividing by 1,000 to change it into kilometers. The distance between the signals, so you've got the acceleration, you've got the time, so this is where you've got most of the stuff, and this is where, you know, on my training video, on my lesson video, the first one, I gave you all 4 formulas. I would use S equals ut plus a half a t squared, because you've got the time, you've got the initial velocity, you've got the acceleration. So by doing S is equal to, again going back to meters per second, 20, it was initially at 20, the time taken is 25, and we're doing plus 0.5 times minus 0.6 times 25 squared. So that is putting those values in to that equation, and stick all that into your calculator, and you get 312.5 meters. Okay, so using that formula. Okay, and again, you know, you can, I used to, when I was learning these, I used to do a little checklist. I used to go right down to that, what did I needed that one. Okay, I've got that, I've got that, and I've got the time. So I used to tick those off. Which equation has those 4 things in it, S, U, A, and T? That's the only one. Okay, you need that one, you've got that, that, and that. Okay, which equation of those 4 does it tie into? It only ties into that one. That's the only one that has S, U, A, and T in it. So you can do that little checklist like I used to do when I was a little boy. Okay, so that's number 7. So a little bit different, that one, because you had to change the units to SI units. Number 8 looks like that, and I've done this in pen because I was worried about using all my ink up on me. I hope you can read that one. So a particle moves from A to B with constant deceleration, and it would have said in the book like in a straight line. So from A to B, there's A and there's B, with constant deceleration of 4 meters per second squared. So I'm going to go minus 4 meters per second squared. At A, it has a velocity of 32, so that's his initial velocity in the start of this simulation. So that's U is 32. I'm not going to put all the units on, I suppose I should. And at B, it comes to rest. So V here is equal to 0. And just checking Okay, so for this one here, the time, do I need to go through this one? It comes to rest of the time taken for it to get from A to B. Well, what have we got? So using my little method, S, U, V, A and T, we've got U, we've got V, it comes to rest, we've got the acceleration, and it's asking for the time, so that's the one it's asking for. V, U, A and T, the only one I can think of that has all those is V equals U plus A, T. So that's the one you use. You just put V as naught in, so it's naught after however many seconds that we don't know, and you're starting with 32 minus 4 T. And you simply go in 4t is equal to 32, divide by 4, and t is equal to 8 seconds. Okay, you can see that takes 8. And the distance from A to B, again, so I can write that in now, 8 seconds. I would, you've got everything now, so you can, the distance, there's different formulas you can use for this one. But because you've got the velocity, you can use v squared equals u squared plus 2as if you want. You can use that one. Because you're only trying to find that, you know that, you know that, you know that. So you can use this one to find the distance between A and B. You can use s equals ut plus a half at squared as well. So you can use that one. I'll just use this one just to be different because I used the other one last time. V squared is 0, u squared is 32 squared, plus 2 times the acceleration. Well, 2 times minus 4 is minus 8s. So you've got minus 8s. You take all of that over to the other side and you've got 8s is equal to 32 squared. So the distance between them is 32 squared divided by 8, whatever that is. There's my calculator. So 32 squared divided by 8, and it tells me it's 128 meters. Okay, you could have used s equals u t plus a half a t squared on that, and that would have given you, without rearranging, u was 32, so 32 times 8, and then this is plus a half times minus 0.4 times 8 squared. All of that would have given you 128 as well. So either one of those formulas would have done that, either one of those two. Okay, so that was number 8. I hope I'm not going too fast. Surprising myself actually, just thinking of me homemade pizzas. That's what it is. I am fairly slow, as you know if you've watched these videos before. So, right, a skier travelling up a hill experiences constant deceleration. At the bottom of the hill, the velocity is 60 meters per second, but after moving up the hill 40 seconds, he stops. So what's happened here? So this is the hill, and there's a little bit of that if you've ever been skiing, and here he is, okay, on his skis. So he's gone down, speeded up, and at the bottom of the hill, he's obviously gone around the bottom and he's gone up a little bit, slowed down and sort of stopped. So it's this bit here that we're looking at. So he's gone down, speed up, and then it's the bit that we're looking up here. Okay, so that's what that is describing. Okay, you get the extra art for free there. So at the bottom of the hill, so let's do it as a straight line again. So at the bottom of the hill, there's my straight line. This is going to be 40 seconds long, isn't it? So that point t is equal to 40s there. We don't know that distance. We're going to find that. The velocity at the bottom of the hill, the velocity is 16. So u is equal to 16. The initial velocity is 16. The velocity here is 0. And what are we doing? Moving up the hill for 40 seconds. Yep, so we've got everything now. What are we going to use? So I've got u, I've got v, I've got t, and it's only the acceleration that we need. So to me, it looks like our old friend v equals u plus at for this one. Velocity is 0 when he stops. Initial velocity was 16. when he hits the bottom of the slope and when our simulation starts, plus acceleration we don't know, but we know that the time is 40, so 48. And watch what happens here. The maths takes care of itself. So if we take the 16 over to the other side, take 16 off both sides, we get minus 16 is equal to 40a, and divide by 40, we've got a is minus 16 over 40. Now minus 16 over 40, that cancels down to minus 2/5, or if you want, minus 0.4. So that means the acceleration minus 0.4 is telling you that he's slowing down. It's a deceleration, isn't it? So the deceleration, you wouldn't, when it says give a deceleration, you wouldn't say minus 0.4. You'd say the deceleration is 0.4. Use the words deceleration to say slowing down, or put slowing down by 0.4 meters per second squared. And the distance travelled, and I am going to go with one of my favourites, got me out of many a scrape in the past, this when I've got into trouble. V squared is equal to u squared plus 2as. Going to use this a lot when v is 0. We'll talk about that in the next lesson. But the velocity is 0, so 0 squared is 0. We've got 16 squared because that was the initial, plus 2 times minus 0.4. And this time, am I doing this one right? No, ignore that. I'm talking absolute rubbish. Yeah, we can use this one. Okay. Actually, no, we can use that, but this one, actually, you can just go, yes, the really sort of simple one, u plus v times t. That's even easier, that one, isn't it? So s is equal to a half of you. Sorry, you could have used that one that I put in. This one's even easier. So 16 plus 0 times the time, which is 40. That's much better, isn't it? 8 fours are 320 meters. That's an even better one. Okay, so S equals a half u plus v times t. So sorry about that. Okay, I should have stuck with that one. Okay, so the other one just used the acceleration, but it would have given us 320 meters the same. Okay, I just was looking at that then as I was doing it, thinking, oh, there's a simpler way of doing it than this. Okay, so that's number 9. What are we doing now? I'm going to miss out number 10 because they're all getting a little bit samey, but I am going to go through number 11 because this is a particle that's moving from A to B and then it moves from B to C, so let's do that one. So here it is. So let's give myself a little bit more space. In fact, put it there. So a particle moves from A to B, A to B, with an acceleration, and it will say constant acceleration in the book. Use extra words. Constant acceleration. It then moves from B to C with a different acceleration. At A, it is 1 meters per second. That's u is there. At C, it is 43 meters per second. Oops. There, 43 meters per second. It takes 10 seconds to go from there to there, so t is 0, t is 10, and it takes from A to B, and 10 seconds from B to C. I think I got that wrong actually in the book. I was going to change that with liquid paper. Number 11. I think I put it takes 12 seconds to move from A to B. Sorry, that is meant to be a 12, so that's 12. Yeah, and then it takes 10 seconds to move from B to C, so that is t is equal to, what's 10 plus that? 22 seconds. There we go. Okay, so this distance here, I'm just putting that in, that takes 12 seconds, and this leg here takes 10 seconds. Yeah, sorry about that. Okay, so this is number 11. So what are we trying to find? We're trying to find the velocity at B. So just ignore all of that now. We're just looking at this. We're just going to use for A the velocity at B. We've got U, we've got acceleration, we've got the time, so we're just going to use V equals U plus AT for that. So the velocity at B, initial velocity is 1, plus the acceleration 1.5 times, took 12 seconds, didn't it? I wrote that down wrong. So, and if you work all that out, 18 and 1 is 19 meters per second to the minus 1. So that's the velocity. Part B, the acceleration from B to C. Again, we can use, we've got the velocity, we've got the initial velocity now. The initial, if we just look at this leg, we can start again, we can pretend it's starting from here. If it starts from here, the velocity is now 19 meters per second. And if we just look at this leg from there to there as if we were starting from scratch, we can say we can use this as our U, our initial velocity of just this bit, and pretend this never happened. So we can use V equals U plus AT again. The initial velocity now is the 19, it becomes 43. The acceleration we don't know, but the time we know it takes 10. So let's just change that 10A. So we've worked out the velocity there, but in this, just considering this leg as a separate leg, because it changes there, it changes acceleration. We can create this formula. So we take 19 off both sides, so that's going to give us 24 is equal to 10A, and then divide by 10, so A is equal to 2.4 meters per second to the minus 2. So the acceleration here is 2.4 meters per second to the minus 2. Okay, and the distance from A to C, well, it changes acceleration, doesn't it? So let's just have a look at this leg and look at this leg. So for this leg, we'll use, learning the lesson from that last question actually, the distance is, we'll just use this one, U plus V times time. And if we do that, we're just going to go, the distance is a half of 1 plus 19, oh that's handy, isn't it, times 12. So 20, half of 12 is 6, 20 times 6, so S is 120 meters. And this one, S is equal to a half of U plus V times T, and a half. Now the initial, just looking at this leg again, the initial velocity is 19 plus the 43, and oh, that's easy, 10 then. So 19 add 43, 53, 63, 62. Half of 62 is 31 times 10, 310. There we go. So the total distance travelled from A to C is those two added together, isn't it? Which is 430 meters. Okay. Right. Family's getting hungry. Pizzas are rising. I know pizzas don't rise, but I've got them sort of in buns, and then you flatten them out, and they're superb. They are. I'm a master chef as well. So here we go. So we're looking at number 12 and number 13. The last two, they're going to be the most difficult. A cyclist travels with constant acceleration of x meters per second from rest to 5 in 20 seconds. She then decelerates from 5 meters per second to rest with constant deceleration. Fine, okay. So there she is. Accelerates to this point from rest. So U is equal to 0. She goes from rest to a velocity of 5 meters per second to the minus 1, and that's in 20 seconds. Okay, so this is t equals 0 and this is t equals 20. The acceleration is x meters per second to the minus 2. We don't know that. And then after that, she decelerates with constant deceleration to there. From constant, she decelerates from 5 to rest. So here, the velocity is 0. And we don't know how long that takes, but the acceleration here is half of x meters per second to the minus 2. And it's going to be minus because it's a deceleration, so whatever that is, it's going to be half minus half of that. So that's number 12. That's our diagram for that. So the first one, find the value of x. Well, it's not that hard because you've got v, you've got u, you've got t, so it's just our friend v equals u plus at, isn't it? So the velocity is 5, started from rest, so the initial velocity was 0, plus we don't know the acceleration, and the time was 20, so 20a. So you can see here, divide both sides by, so you've got 5 is equal to 20a, and divide both sides by 5 and you get a quarter is equal to a. So x, the acceleration, is a quarter meters per second to the minus 2. So that's what the acceleration is. So that means that this here, half of a quarter, is an eighth. So that's minus an eighth meters per second to the minus 2. It wasn't that bad, that really. Now this is where we're, what are we doing? We're finding the total distance travelled. So we on this one here, for this leg, this first leg, if we do the s equals a half of u plus v times t, if we do that, we've got s is equal to a half of 0 plus 5, which is just 5, and the time took is 20, so 10, so that's 50 meters. That leg took 50 meters. This one here, you can't use s equals ut. You've got, what have you got? Can you use, you've got u, you've got v. You haven't got the time it takes to go from there to there for this second one. So you can do it in 2 legs, but if you use that formula this time, v squared equals u squared plus 2as, it will work in one go, because the only thing that you don't know there is the s. We've got the acceleration, we've got the velocity, and we've got the initial velocity. So the velocity at the end is 0, so 0 squared is 0. The initial velocity, this is, we're just looking at this leg now, the initial velocity is 5, so 5 squared is 25, plus 2 times minus an eighth times s. Okay, so that becomes minus a quarter s. Take that over to the other side, and you've got a quarter s is equal to 25, times both sides by 4, and you get s is equal to 100 meters. And you've done that in one go using that formula, and in the book they haven't taught you that formula for this particular exercise, so that's why it's best to learn them all, and it's a much quicker way of doing it then. Otherwise you would have to use v equals u plus at, find the time, and then use this formula. So use one formula and then substitute your time into this one to get your 100. So now you can see that that cyclist has travelled 50 meters from there to there and 100 meters from there to there, so 150 meters altogether. Okay, and then the last one, and I know you're getting unbelievably bored. Well, I would be if I'd watched me go through 6 questions. So I hope you're only picking and choosing on these ones, because otherwise you'd lose the will to live by now. So an accelerating particle passes through A, B and C. So this one looks good fun. So A, B and C. So let's label that A, B and C. And at A it's 20 meters per second to the minus 1. At B it's 30 meters per second to the minus 1. At C it's 45 meters per second to the minus 1. It moves from A to B in t 1 seconds, and it moves from B to C in t2 seconds. Show that t1 over t2 is equal to 2 over 3. Okay, well, we've got the velocity, the initial velocity. We're talking about that. We've got the velocity, the initial velocity. We've got the time, t1. We're just going to refer to it as t1 and t2. The only thing we haven't got is the acceleration, but we've got two equations, two unknowns, so no problem. If I go v equals u plus at for this one, remember the acceleration, you know, it says accelerating through A, B and C. It does say in the question with constant acceleration. So the acceleration is the same, you know, all the way from there to there. V equals u plus at. So velocity is 30 is equal to 20 plus at1. Take 20 off both sides, just tidy this up. 10 is equal to at1. And if we do it for this one, v equals u plus at, just looking at this leg here, the velocity, the initial velocity is 30 and it becomes 45. So there we go, that becomes our initial velocity there, plus a, and the time is t2, but the acceleration is the same as this one. So tidying it up, take 30 off both sides, 15 is equal to a t2. Now a is the same, so let's eliminate a. If we divide both sides by t1 here, we get 10 over t1 is equal to a, and we get 15 over t2 is equal to a. So you can see what I'm doing. I'm going to put those two equal. So I'll do that up here, and I can go 10 over t1 is equal to 15 over t2. Now what do I want? I want t1 over t2, so move that up, move that diagonally down, and I've got 10 over 15 is equal to t1 over t2, and that cancels down, you can see, to 2/3 is equal to t1 over t2. So that's done. If it takes, where are we? If it takes 50 seconds to travel from A to C, find the distance between A and B. Okay, so it takes 50 seconds to travel from A to C. Okay, so let's do that then. Can I just rub that one out? So from there to there, 50 seconds. Okay. So let's just consider, let's forget about this middle part B, let's just ignore that now. So if we just use V is equal to U plus AT, we just use that. The velocity, going in blue, the velocity is 45 when the initial velocity was 20 plus A times 50, so 50A. So if we do that, we've got 25 is equal to 50A, divide by 50, and we get a half is equal to the acceleration. And now we've got that constant acceleration all the way across. So we know that that acceleration is equal to a half meters per second to the -2. So we've got more information now. So that means it's accelerating at a half from there to there and a half from there to there. And it now just wants the distance, not the whole distance, just between A and B. So just between A and B, we can, what are we going to do for between A and B? Yeah, so we're going to use this now. We're going to use this v squared is equal to u squared plus 2as. I was just thinking about doing v equals u plus at, getting the time, and then using the s equals a half. But we can do it with this one now. So for this one, this is the quickest one because you can do it in one go, in one equation. So the distance is there, that's what we're trying to get, the displacement. So in this leg here, the velocity is 30 squared after an initial velocity of 20 squared plus 2 times a half, because that's the acceleration times s. So this, if we take this away, we've got 30 squared, take away 20 squared is equal to 2 times a half, is just 1, is just equal to s. And 30 squared is 900, take away 400 is equal to s, so s is equal to 500 metres, and that's the best way of doing it. Okay. And I hope that's okay. So that takes us up to 13. That's the end of the questions. Fill in the gaps. Have a go at those before. Oh, I should have said this at the beginning. I think I did. Have a go at those before you watch me do them. And we'll look at exercise 9D next. Okay, I know it's a long video. I hope you didn't just sit and watch it all. But if you did, it will have helped you get to sleep. Okay, bye-bye. Off to make my pizzas.